Welcome to Bite-Sized Data Science. We continue to explore model characteristics with Eric Martens. This time, we talk about drift.
Hello once again. Thank you one last time, Jacques, for letting me come on your channel to talk about model trust. It's certainly an important topic. No matter how good your data gathering and modeling techniques are, if you can't convince others to trust the model outputs, then you won't get any real-world value from all your hard work. In previous videos, I talked about ways to explain predictions and detecting unfair bias. Today, I'd like to cover a third requirement for trusting your model, dealing with changing data conditions, or drift. Though not all models are subject to drift, most real-world problems deal with changing conditions over time, especially those trying to model human behavior in the face of shifting technological or cultural trends. There are two types of drift: concept drift and data drift. Data drift is a change in the distribution of the input variables to a model. One popular example is identifying senders of text spam. Using the number of messages sent per hour used to be a viable way to identify spammers, as they would send significantly more texts than a normal user. However, as text messaging became the de facto method of communication for some age demographics, the distribution of that feature changed and the metric lost its predictive power. Concept drift is a change in the relationship between the model inputs and the variable we want to predict. Offhand, it's easy to think of dozens or hundreds of examples, predicting cell phone data usage in the introduction of the iPhone, foot traffic at retail locations when a new apartment building goes up across the street, toilet paper demand during a global quarantine. Obviously, these are all major events that can invalidate any model, but drift can happen gradually over time as well. Think about snowfall prediction models dealing with climate change, or housing price models when neighborhoods begin to gentrify. The point is that nearly all models exist in dynamic, changing environments, and that can drastically affect model performance. The best way to deal with drift is to continually evaluate the model with new ground truth data and refit it as often as possible. In many cases, such as in our climate change example or the polling model used by 538 to forecast elections, it may be helpful to assign greater weights to more recent data points to catch emerging trends. It can also be helpful to look at the distributions of individual features to both see how they change over time and to see how they correlate with model predictions. Finally, you can also try and model the drift. Watson OpenScale, IBM's solution for model monitoring, compares inputs to the model with the training data and checks for characteristics that the model struggles to predict correctly, then uses that information to forecast drops in model accuracy. For instance, let's say we've built a model to assess credit risk. That model is less accurate for people in the 18 to 25 age group, but the bank we work for has identified college students as a potential growth market and targeted them in an aggressive campaign. Even without additional ground truth data, we can forecast a drop in model accuracy unless we take steps to improve our model for this demographic. In a perfect world, our models would age like fine wine. Unfortunately, the real world is a lot messier, and models are built more like automobiles, requiring continual upkeep and maintenance. Today, we looked at concept drift and data drift and how they can decrease model accuracy over time. Finally, we talked about a few strategies for reducing the effects of drift to keep your models running smoothly. Thanks for tuning in.
Trusting a model requires explainability, measuring its fairness, and staying on top of the potential drift. All this to say that once a model is deployed, it is just the beginning. See you next time on Bite-Sized Data Science, and don't forget to subscribe.